Okay, in this lesson we're going to be using something that you're familiar with, something that you've seen before, but it's the quadratic formula. Now, some students are familiar with the quadratic formula, but they have no idea why or how or when we use it. So it's important to recognize that the only time that we can use an equation is when we have an equation in the form ax squared plus bx plus c equaling 0. Remember, it has to equal 0. If it's not equal to 0, we're going to have to rewrite the equation to get it equal to 0. And when you have it in that form, again, you can use the quadratic formula, which is this: ax squared plus or minus the square root of b squared, opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Again, notice how I say it's the opposite of b, because it's important to think of it that way, so that way b is already negative. You're familiar with taking the opposite of it and not keeping it as a negative value. But it's a negative b plus or minus, and we'll talk about that plus or minus here in a little bit, the square root of b squared minus 4ac, the whole thing, not just the square root portion, but the whole thing is divided by 2a. Now, why is it that we use this? Well, a couple of reasons. First off, when we're using this equation, what we're doing is we're solving for x. We're finding out what the value or values of x are. Often case it's going to be two values, there's going to be two answers for x, but there are some situations where we end up with one value for x. Now, there's another point too to emphasize, and that's that what we're actually finding is we're finding the x-intercepts, because if you recognize ax squared plus bx plus c, that's the standard form of an equation, of a parabola, which is y equals ax squared plus bx plus c. So if we replace y with 0, what we're finding is we're finding the x-intercepts. So if you're ever asked to find the x-intercepts of a parabola, just use the quadratic formula and you'll get those. Now let's look at some examples where we're going to have to use it. Again, you're going to have to memorize that quadratic formula, so if you don't know it already, you're going to want to write it down every time you use it to make sure that you get it right. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So for this one, b is a negative 5. This is why I emphasize that it's the opposite of b. Oops, it's not y equals, it's x equals. So it's going to be x equals the opposite of b, so it's going to be 5 plus or minus the square root of b squared, so negative 5 squared, minus 4 times a in this case is 1, times c, which is negative 14. The whole thing, not just the square root portion. I see this all the time where students just write it down like this. Well, that's wrong, and they end up getting the wrong answer. Even though they have everything set up right, the fact that they just forgot to extend that line out throws off their entire answer. And 2a, well, a is 1, so I'm just write it out. 2 times 1 is just 2. You need to do this in steps. I don't want to see you write out this and write down a final answer. I want you to see this. I want to see your steps. Our first step, using order of operations, is to simplify inside the grouping symbols. So to do that, negative 5, when you square that, it's a positive 25. The reason why it's important to do this in steps is because oftentimes people will type this in on their calculator and forget to put negative 5 in parentheses, and their calculator will make that a negative 25, but they won't catch that mistake because they just typed it all in at once. So if you do this piece by piece, you can catch those little mistakes. Well, negative 4 times 1 is negative 4. Negative 4 times negative 14 is a positive 56. And all that is going to be divided by 2. Now I can add those together. 25 plus 56 is going to be 81, all divided by 2. And I know that the square root of 81 is 9. So I'm going to write this now as two different answers. Because x could be 5 plus 9, because a plus or minus means that there's going to be two possible answers. 5 plus 9 divided by 2 and 5 minus 9 divided by 2. So 5 plus 9 is 14 divided by 2 gives me 7, so that's one of my answers. The other one is that 5 minus 9 is negative 4 divided by 2 gives me negative 2 as my answer. So I have two answers for x. X could equal 7 or negative 2. Let's try the next one together. Now, do you notice a problem with this next problem? If you don't, remember, the equation has to be set equal to 0. So before I can jump into using my quadratic formula, I have to get it equal to 0 by subtracting 4 from both sides. When I do that, I get b squared minus 4b plus 4 equals 0. Now I can go ahead and use the quadratic formula. So it's going to be the opposite of b, which is a positive 4, plus or minus the square root of b, which is negative 4 squared, minus 4 times a is 1, times c, which is 4. All over 2a, a again is 1, so 2 times 1 is just 2. So again, you want to take these piece by piece. So we start out with simplifying these two parts inside the radical. Negative 4 squared is 16. Negative 4 times 1 is negative 4, times 4 is also negative 16. All divided by 2. Well, if you notice, 16 minus 16 is 0, and the square root of 0 is still 0. So this is one of those unique problems where we don't have two answers. Because we end up with 4 plus, this is all 0. 4 divided by 2 is just 2. So this one here, I get an answer of just that, x equals 2. There's not two answers, just the one. Okay, I want you guys to try this one on your own. Notice a couple of things that are different about this one. Not only is it not set equal to 0, but also you do have a value for a here. So you'd have a value of a, that's 2. So make sure that you include those in your quadratic formula. And also make sure, like I said, that you set this equal to 0 first. So why don't you guys go ahead and pause the video and hit play when you're ready to check your answers. Okay, let's see how you did here. So again, your first step should have been to subtract 15 from both sides. When we do that, we get 2x squared minus 3x minus 5 equals 0. Now I can go ahead and use my quadratic formula. So I'm going to use the opposite of b, which is a positive 3, plus or minus the square root of b squared, so it's going to be negative 3 squared, minus 4 times a this time is 2, times c is a negative 5 this time, all divided by 2 times a. Well, 2 times 2 is 4. Simplify these two parts under the radical. Negative 3 squared is a positive 9. Negative 4 times 2 is negative 8, times negative 5 is a positive 40. All again divided by 4. So now we get 3 plus or minus the square root of 49 divided by 4. Well, I know the square root of 49 is 7, so I have 3 plus 7 and 3 minus 7 all divided by 4. So 3 plus 7 gives me 10. Divided by 4, which reduces to 5 halves, or you could write it as 2.5. Oops. And then the other part of our answer is that x could equal 3 minus 7. Well, 3 minus 7 is a negative 4 divided by 4 gives me negative 1. So our two answers are that x could equal 2.5 or negative 1. So hopefully you got those right. Hopefully you're remembering how to use a quadratic formula. Again, it's important to not only have it memorized, but to know why you're using it. We're using it to solve the equation when it's equal to 0, which in essence is finding our x-intercepts. So hopefully with all of this, you will do fine on your assignment. So good luck.